Alright, a compound inequality is a combination of two inequalities. And so there's two kinds of compound inequalities. They can involve the word and they can involve the word or. So let me give you some examples. Alright, so let's say we have x is greater than 2 and x is less than 6. Those are two different inequalities that when we combine them we make a compound inequality that looks like this. Notice the smaller number is to the left and the larger number is to the right. So the way this is going to work is I'm going to show you just how the inequalities look separately and then show you why it's considered a compound inequality. So x is greater than 2. If I was graphing that, I would put my circle on my 2 and shade everything to the right. And I'll just make it really obnoxious. So this is x is greater than 2. X is less than 6 looks like this, where we've got a circle here and everything to the left is going to be shaded. So all of this represents x is less than 6. Both of them put together, they make a compound inequality. So 2 is less than x and x is less than 6 means every part that they share together, which is all of this right here, these two things right here, that's what's going to be combined on the compound inequality number line. So this number line right here, here is 2, here is 6, here is both of them together. So this is the inequality. This shows what 2 is less than x, which is less than 6, looks like. So this means that the solution to the compound inequality is x can be anything between 2 and 6. It's just going to be greater than 2, but it's going to be less than 6. Okay? Now there's or inequalities, and that's when it's either or, meaning x can't be less than or equal to 2 and it cannot be greater than or equal to 6. So that's called a or compound inequality. It's going to be one or the other. So just to show you, here is x is less than or equal to 2. We're going to fill in our circle, and so x is all of this. So this is x is less than or equal to 2. X is greater than or equal to 6 looks like this. This is x is greater than or equal to 6. Now there's no fancy way to combine them like we do with the ands. See how we can combine them and write it a more concise way? We can't do that with the ors. This is the only way that you can write it. So the compound inequality, both of them on the same number line, it's just going to look, you just put them on the same number line. Okay, so this is what the compound inequality, x is less than or equal to 2, or x is greater than or equal to 6. Now again, x can only be here or here. It can't be -1, x cannot be -1, and x cannot be 9. It can only be one or the other. This solution means that x is somewhere between, x cannot be anything between 2 and 6 though. It can be 2, and x can be 6, but it can't be between 2 or 6. Okay? Now when you're solving compound inequalities, there is a little bit of difference from solving regular inequalities in that you've got two inequality symbols here. So really, instead of having two parts when you have one inequality symbol, now you've got three parts to keep track of. So the idea here when I'm solving a compound inequality is that I want to isolate the variable. I want to figure out where x is, what range x is in. And so to do that, I'm going to start by subtracting 1. Well, if I subtract 1 from here, I have to subtract it from all three parts. So like I said, instead of just having to worry about two sides, now you've got to worry about 3. So when I simplify it, -1 minus 1 is -2, is less than. X plus 1 minus 1 is x. And then 1 minus 1 is 0. So that means x is somewhere between -2 and 0, just not equal to -2 or 0. So let me graph each of these. Here's my, oops, I'm not coloring that in. And then here is the 0. So x is somewhere between these two because x is greater than -2, but it's less than 0. So x is somewhere here in this range. Alright, so let's try this one. Again, we've got our three parts, so I'm going to subtract 2 because I want to isolate the x. I want to isolate the variable, get it by itself, but I have to subtract 2 from all three parts. And when I do that, 4 minus 2 is 2, x plus 2 minus 2 is x, and x minus 8 is 6. So that means x is somewhere between 2 and 6, but it can also be equal to 2 and 6 because of that or equal to part. So here is my 2, here is my 6, and everything in between. Okay? And then with the ors, when you're solving these, just treat them as two separate inequalities that you're graphing on the same number line. So 2x plus 1 is less than 1. I'm going to subtract 1 from both sides. So I'm left with 2x over here is less than 1 minus 1, which is 0. Divide both sides by 2. So x is less than 0. Then I've got this other inequality over here. Let me change colors. I'm going to subtract 5 from both sides. So x is greater than 3. These are the two inequalities that I am graphing. So this is saying that x is less than 0 or x is greater than 3. So here is my 0. I'm going to shade it going to the left. And then x is greater than 3. I'm going to circle that and shade it to the right. So if you notice, the ors, the lines are going out, whereas with the ins, they're shaded, there's like a segment shaded in the middle, or you know, part of it, a chunk of it.